Hey everyone, welcome! Ready for another deep dive? Today we're tackling Kubernetes, also known as K8s.
Ah, Kubernetes.
We've got some excerpts from Kubernetes Made Easy, a guide that promises to demystify this powerful tool for managing containerized applications.
Sounds like a plane.
So, by the end of this, we should all have a better grasp of how Kubernetes can really benefit us, especially for dealing with applications at scale.
Absolutely. Especially in today's world where applications are becoming increasingly complex.
Okay, so let's jump right in. The guide starts by talking about the need for something called container orchestration.
Right. Container orchestration. It's a bit like having an invisible stage manager,
Yeah.
one that keeps your applications running smoothly no matter how complex or demanding they become.
Okay, I can see how having a stage manager would be helpful, especially behind the scenes, but what are they actually managing?
Well, think about it.
Yeah.
You're dealing with hundreds, maybe even thousands of containers.
Oh, wow, yeah.
Trying to deploy those across multiple servers, scaling them up and down as needed, and making sure they can all talk to each other.
Yeah, it sounds like a lot to keep track of.
It would be a logistical nightmare to do manually.
Yeah.
That's where container orchestration steps in.
So it's like a traffic control system.
Yeah.
For containers, making sure everything flows smoothly and nothing crashes.
That's a great analogy. A super smart traffic system.
Oh.
One that not only directs traffic, but also can, repair roads and reroute vehicles automatically if there's an accident.
Mm-hmm.
Kubernetes is that system.
I see. So it's not just about keeping things moving, it's about making sure the whole system is resilient.
Exactly. It can adapt and recover from problems, which is essential when you're dealing with complex applications.
Now, I noticed the guide mentions Docker Swarm as another player in this container orchestration game.
Yeah, Docker Swarm, good one too.
How does Kubernetes stack up against Docker Swarm? Are they both doing the same thing?
They both handle container orchestration, but they have different strengths. Think of it like this. Docker Swarm is great for smaller projects, where you prioritize ease of use.
Okay.
Kubernetes, on the other hand, is more robust. It's packed with features, making it the preferred choice for large-scale, complex deployments, those that demand both power and flexibility.
So Kubernetes is more like the industrial strength system,
Yeah, exactly.
while Docker Swarm is more for like personal projects or smaller teams.
Yeah, more like a starter kit.
Got it. And since we're diving into more complex scenarios today, Kubernetes is definitely our focus.
Makes sense. If you're serious about container orchestration, Kubernetes is the way to go.
Now, the PDF calls Kubernetes an open source container management tool.
Yeah.
Not just orchestration, but management. What's the difference there?
Well, it goes beyond simply orchestrating containers.
Okay.
It provides a complete platform for running containerized applications, handling everything from deployment and scaling to networking and storage.
Oh, wow. So it's more than just moving containers around.
Way more.
It's like a whole operating system designed for running containerized apps.
You got it. That comprehensive approach is a big part of why it's so popular.
That makes a lot of sense. And it's interesting to know that it started at Google,
It did.
handling their massive container needs, and is now managed by the Cloud Native Computing Foundation, or CNCF.
It's a big deal in the world of cloud-native applications.
Now, I have to admit, I got a bit tripped up by some of the terminology in the PDF.
The jargon can be a bit much sometimes.
Things like container runtime, container orchestration, container-centric infrastructure orchestration,
Oh, yeah.
and self-healing mechanisms. Can we break those down?
Sure, no problem. Let's start
Ah.
with container runtime.
Okay.
That's the software that actually runs your containers. Think of it as the engine.
Okay, so that's like the bare minimum you need to even get a container going.
Exactly. It's what makes the container, well, a container.
Got it. Then we have container orchestration, which is what Kubernetes is all about, right?
Right. That's the next layer up. It handles deployment, scaling, and networking of all those containers.
So like the conductor of an orchestra,
Yes.
making sure all the musicians are playing in sync.
Perfect analogy.
Yeah.
Then there's container-centric infrastructure orchestration.
Okay, another layer.
It takes it even further, managing not just the containers themselves, but also the underlying infrastructure they run on, things like storage and networking resources.
Wow, so Kubernetes is playing a role at multiple levels. It's managing the containers and the resources those containers need to run.
Exactly. It's the brains of the operation.
Okay, that's starting to make more sense. What about self-healing mechanisms? That sounds almost magical.
It is pretty cool. It refers to Kubernetes' ability to automatically detect and recover from failures.
Oh, so if a container crashes or a server goes down.
Kubernetes will try to fix the problem and keep your applications running smoothly.
Wow, that's impressive. So it's like having a built-in IT team that's constantly monitoring and fixing things behind the scenes.
Exactly. You can sleep better at night knowing that Kubernetes is keeping an eye on things.
No, the source material also mentions Kubernetes distributions.
Ah,
It
yes.
seems like there's more than one flavor of Kubernetes.
There are. Kind of like choosing an operating system for your computer. You've got options, each with its own pros and cons.
Okay,
You could go with cloud-managed distributions,
right.
Amazon's EKS, Azure's AKS, or Google's GKE. These are fully managed services, so the cloud provider handles all the operational heavy lifting.
That sounds convenient, but I'm guessing there are trade-offs.
Of course, you have less control compared to self-managed options,
Like what?
like OpenShift or Docker Enterprise.
Okay, so those give you more control, but they also require more expertise to set up and maintain.
Right, you're more hands-on. It all depends on your needs and resources.
So it's about finding the right balance between convenience and control.
Exactly.
And then there are lightweight versions for development and testing.
Yes, those are great for learning and experimenting with Kubernetes. Micro K8s and Minikube are popular choices.
And I saw something about vanilla Kubernetes. What's that all about?
Vanilla Kubernetes. That's the pure open source version. It's like building a computer from scratch.
Oh.
You have total control, but it's a lot more work.
So for the truly adventurous,
Exactly. And for those who really want to understand how everything works under the hood.
got it. And then there are those specialized builds like K3s designed for like edge devices and resource-constrained environments.
Yeah, it's pretty cool how Kubernetes is adapting to these new environments.
It is. And the PDF even links to an online emulator, a safe space to play around with Kubernetes without breaking anything.
Definitely a good place to start if you're new to Kubernetes.
Okay, so we've talked about why Kubernetes is important and the different flavors it comes in. Let's dig into Kubernetes architecture.
Let's do it.
This is where we get a look under the hood, right?
Exactly. We'll
Yeah.
see how the engine runs. At the heart of it, we have the master node and the worker nodes.
Okay, and the PDF describes the master node as the control center
Yes.
and the worker nodes as the workhorses. What's the breakdown of their roles?
So the master node, it's like the brain of the whole operation.
Okay.
It manages the entire cluster, hosting critical components like the API server, the scheduler, the controller manager, and etcd.
Oh, wow. A lot of important stuff happening there. And those worker nodes, what are they up to?
They're the ones doing the heavy lifting. They run your containerized applications.
Yeah, so that's where the actual work gets done.
Each worker node runs a kubelet agent, which takes orders from the master node, and a kube proxy, which handles networking within the node.
So the master node is like the general giving commands, and the worker nodes are the soldiers carrying out those commands.
I like that analogy. It's a well-coordinated team effort.
And remember, K3s, that lightweight version,
Yeah.
it has a similar architecture, but streamlined for efficiency, right?
Right. It's designed to run on devices with limited resources, so it has a smaller footprint.
Speaking of K3s, the PDF mentions setting it up using VirtualBox.
Ah, VirtualBox. A great tool for experimenting with different operating systems and environments.
Any tips for someone who wants to try out K3s that way?
Absolutely. Make sure you configure a host-only network adapter
Okay.
and disable DHCP. This will let you assign static IPs to your virtual machines.
Okay, so static IPs are key for smooth K3s setup.
Absolutely. It ensures stability and communication within your cluster.
Now, we've mentioned these pods quite a bit.
The heart of Kubernetes.
They seem to be at the heart of how Kubernetes works. What exactly is a pod?
A pod is the fundamental building block of Kubernetes.
Okay.
Think of it as a container, but with extra capabilities.
The guide says a pod is the smallest deployable unit in Kubernetes.
It is.
Does that mean it can contain more than just a single container?
Yes. A pod can actually encapsulate one or more containers that are tightly coupled and share resources like storage volumes and network interfaces.
So it's like a team working on a project. They might have different roles and skills, but they're all contributing to the same goal.
Precisely. And just like you might have multiple teams working on different projects, Kubernetes can have multiple instances of the same pod.
Yeah.
This ensures redundancy and high availability.
Got it. So how does Kubernetes handle scaling these pods when you need more resources?
That's where the orchestration magic really shines. Scaling in Kubernetes happens at the pod level, not the individual container level.
Okay.
So if you need more resources, Kubernetes creates more instances of the entire pod. All the containers within it scale together seamlessly.
So it's like duplicating the entire project team with all their skills and resources to handle a larger workload.
You got it. Much more efficient and manageable than trying to scale individual components separately.
Now, the source material mentions something called init containers, which sounds like they add another layer to this pod structure.
They do
What
it.
are those all about?
Think of them as specialists brought in to prepare the environment before the main team starts working.
So they handle tasks that need to happen before the main application starts.
Exactly. Like setting up configurations, running database migrations, or downloading dependencies. Once the init containers are done, the main containers can launch smoothly.
Okay, so they're like the setup crew that comes in before a concert to set up the stage and sound system and lights.
I like that.
They're the ones making sure everything is ready for the main event.
Exactly. The unsung heroes of the Kubernetes world.
Now, we've got these pods all set up, but how do we tell Kubernetes what to do with them? How do we manage all these moving parts?
There are two main approaches, imperative and declarative.
Okay.
Imperative commands are great for interactive experimentation. You're basically telling Kubernetes exactly what to do.
Okay, so that's like giving step-by-step instructions.
Right. You can use the Kubecle command line tool to directly create, delete, or manage pods on the fly.
That sounds pretty straightforward.
It is, but for production environments, the declarative approach is preferred.
Okay, how is that different?
Instead of typing commands, you define your desired state in YAML files, called manifest files.
So we're not giving Kubernetes step-by-step instructions.
Yep.
We're describing the end goal, and it figures out how to get there.
Exactly. You give Kubernetes a blueprint, and it handles the construction.
That sounds a lot more scalable, especially as things get more complex.
It is. It's the preferred approach for managing applications at scale. It allows for version control, automation, and easier collaboration.
And the PDF even provides some basic kubectl commands for managing pods, like kubectl get pods or kubectl describe pod,
Those are essential commands.
even kubectl delete pod.
Yeah, you'll be using those a lot.
They seem pretty intuitive.
They are. Kubernetes strives for user-friendliness. These commands give you a simple dashboard to monitor and manage your application.
Okay, so we've got our pods up and running. What about high availability?
Right.
And load balancing. What if one pod fails or we get a sudden surge in traffic?
That's where replication controllers and replica sets come in.
Okay, tell me more.
They ensure that multiple instances of your pod are always running, providing redundancy and preventing downtime. Imagine a website with only one server.
Yeah, that's a single point of failure.
If that server goes down, the entire website goes down with it.
Not good. So having multiple replicas of a pod means that if one fails, the others can pick up the slack.
Exactly.
Users don't even notice the interruption.
Seamless.
It's like having a backup generator that automatically kicks in if the main power goes out.
Precisely. That's the beauty of replication.
And then there are deployments, which seem to be yet another layer on top of these replica sets.
They are?
Why do we need so many layers?
Think of it this way. Each layer builds upon the previous one, offering more control and features.
Okay.
Deployments are the preferred way to manage replica sets
Why is that?
because they streamline updates and rollouts.
Okay, and I think the source material mentions something called rolling updates. What's that all about?
Rolling updates let you deploy new versions of your application gradually, replacing old pods with new ones without any downtime.
So it's like changing a tire while the car is still moving?
That's a great way to put it. Deployments make updating your applications much smoother and less disruptive.
I see. So we've got these pods, replica sets, and deployments all working together to keep our applications running smoothly. But as our applications grow and we have more and more pods running, it seems like things could get pretty messy without a way to organize them.
Absolutely, organization is key.
That's where namespaces come in, right?
You got it. Namespaces are like folders on your computer. They help you keep things organized.
So as your applications get more complex,
Yes.
and you start running multiple projects or services within a single Kubernetes cluster, you need a way to keep things tidy.
Exactly. Namespaces provide logical divisions within your cluster,
Okay, I like that.
preventing conflicts and ensuring that each team or project has the resources they need without interfering with others.
So instead of having everything jumbled together, we can create separate namespaces for different teams or projects,
You can.
or even environments like development, testing, and production.
Exactly.
Yeah.
It's all about creating clear boundaries and separation of concerns.
The PDF mentions that Kubernetes starts with 3 default namespaces.
Yes.
Default, kube system, and kube public.
Those are the basic ones, yep.
What are those for?
Default is your general purpose folder where objects go if you don't specify a namespace.
Okay.
Kube system is a restricted area,
Oh.
reserved for Kubernetes' own internal components.
So we shouldn't mess with that one.
Probably not a good idea. And Kube public is for resources that need to be publicly accessible within the cluster.
Okay, so it's like a shared folder that everyone on the network can access.
Exactly. It's for those resources that need to be universally available.
So we've organized our cluster with namespaces. But how do these pods actually talk to each other?
Communication is key.
They can't all be shouting across the room, right?
Not very efficient, is it?
No. So how does it work?
That's where services come in.
Okay, services. Tell me more.
Services provide a stable way to access your pods,
Okay.
abstracting away the dynamic nature of their IPs and lifecycle.
Hold on. I thought pods had their own IP addresses.
They do?
Why do we need this extra layer of services?
Well, those pod IPs can change as pods are created, destroyed, or moved around the cluster.
Oh, I see.
Services provide a fixed point of contact, like a phone number that always reaches the right person.
Even if their physical location changes.
Exactly. So even if the pods themselves are constantly moving around,
Yeah.
the service acts as a stable entry point that other parts of the application can always rely on.
That makes a lot of sense. So how do the services keep track of all these moving pods?
Services use labels to keep track of which pods they're associated with.
Okay.
So even if a pod dies and a new one is created, the service automatically updates its endpoint list, ensuring uninterrupted connectivity.
So it's like having a directory that automatically updates whenever someone changes their office.
Exactly. Services are essential for smooth communication within your application.
Now, the PDF mentions 3 types of Kubernetes services: cluster IP, node port, and load balancer.
The three musketeers of service discovery.
I'm assuming these are all about providing different ways for pods to communicate.
You got it. Cluster IP is the default type.
Okay.
It creates a service that's accessible only from within the cluster, perfect for internal communication between different parts of your application.
So it's like having a private internal network for your application.
Exactly. Keeping those internal conversations private.
What about node port and load balancer? Those sound like they're for external communication.
You're right. A node port service opens a specific port on every node in the cluster, allowing external traffic to reach that service.
So it's a way to expose your application to the outside world.
Exactly. It's like opening a door to your application.
What about load balancer services?
Load balancer services are designed for cloud environments. Okay. They provide a more sophisticated way to expose services externally, using cloud provider capabilities to create a cloud-based load balancer that distributes incoming traffic across multiple pods.
That sounds powerful. So it's like having a traffic cop in the cloud directing traffic to the appropriate pods.
Precisely. It's all about ensuring high availability and scalability.
Okay, so Kubernetes gives us a lot of flexibility in how we design our application's communication and access points.
Absolutely. It's all about giving you the tools you need to build and deploy your applications effectively.
This deep dive into Kubernetes is already so much to absorb. It's amazing how much complexity is involved in managing containerized applications at scale.
It is a lot to take in, but it's worth it. Kubernetes is an incredibly powerful platform. Once you understand the basics, it opens up a whole new world of possibilities.
Now, before we move on, I have a question about data. We've talked about how containers themselves are ephemeral.
They are, yeah.
Their data disappears when they're destroyed. How does Kubernetes handle persistent data, especially for things like databases or user files that need to be stored permanently?
That's a great question, and a really important one. Kubernetes provides a mechanism called volumes for attaching storage to your pods.
Volumes, like external hard drives?
Sort of. Volumes act as directories that are accessible to the containers within a pod, allowing you to persist data beyond the pod's lifecycle.
Oh, that makes sense. So even if the pod is deleted, the data on the volume remains intact.
Exactly. It's like having an external hard drive you can connect to your computer. Even if you shut down your computer, the data on the hard drive remains safe and sound.
That's essential for any application that needs to store data long term.
Absolutely. And Kubernetes offers different types of volumes to fit different use cases.
Okay, so we'll dive into those details after a quick break.
You know, one of the things that really impresses me about Kubernetes is how it handles those day-to-day operational tasks.
Right.
You know, we've talked about deployments and scaling, but what about monitoring the health of our applications?
Yeah, that's important.
And actually troubleshooting
Yeah.
any issues that come up. How do we like peek inside these containers and see what's happening?
Yeah, that's a great question. I'm picturing myself as a developer with a Kubernetes cluster running my application.
Right.
Where would I even begin to look if something goes wrong?
Well,
Our guide, Kubernetes Made Easy, doesn't really go into a lot of detail about specific monitoring tools,
sure.
but it does mention some built-in capabilities.
It does, yeah. Kubernetes is designed to be flexible,
Right.
to work with a variety of monitoring tools.
Okay.
But even without any fancy third-party tools, you can get a lot of insight just using the kubectl command line tool.
Okay, yeah, the PDF specifically mentions kubectl logs as a
Yes.
way to get the logs from your pods and deployments.
Exactly.
That sounds pretty basic.
It is.
It's essential.
It's the first place you go to see what's happening inside your application. You can use kubectl logs to retrieve logs from a specific pod,
Okay.
or even filter the logs by labels, containers, or time ranges.
So if I'm seeing an error message in my application,
Yeah.
I could use kubectl logs to see the detailed error messages from the relevant pods and try to pinpoint the issue.
Precisely. It's like having a direct line to the internal chatter of your application,
I like that.
giving you clues about what's going on behind the scenes.
And what if I need to go beyond simply reading logs?
Yes.
What if I want to actually interact with a running container to investigate further?
You can do that too.
Oh, okay.
Kubernetes has you covered. There, you can use commands like kubectl exec
Okay.
and kubectl attach to
Okay.
get more hands-on.
Oh, okay.
Those sound intriguing.
What's the difference between them, you
What's
ask?
the difference?
Well, kubectl exec lets you run a specific command inside a running container.
Oh.
It's incredibly useful for debugging
Okay.
or even running one-off tasks.
So imagine you need to like check file permissions inside a container.
Or maybe restart a particular process. You can do that right from your terminal using kubectl exec.
Exactly. It's like having a remote terminal into the container, allowing you
Oh.
to poke around and see what's happening.
And if you need like a more interactive session, kubectl attach lets you attach to a running container's standard input and output.
That's right. It's like having a live feed from inside the container,
Oh, wow.
allowing you to monitor its activity and interact with it directly.
These built-in tools seem incredibly powerful for anyone working with Kubernetes.
They are
It's like having a whole toolbox
a whole toolbox.
for understanding and managing your application's behavior.
Kubernetes is designed to provide developers and operators with a high level of visibility and control,
Okay.
making it much easier to manage and maintain applications,
Yeah.
even in those complex distributed environments we
Right.
were talking about earlier.
Now, shifting gears a bit,
Okay.
I'm curious about the bigger picture. We've talked about all these individual components of Kubernetes, but I'm interested in how Kubernetes as a whole is evolving.
Okay.
What are some of the key trends and innovations?
That's a great question. Kubernetes is far from a static platform.
Sure.
It's constantly evolving to adapt to new trends
Right.
and challenges in the tech world. And one of the biggest trends we're seeing is the rise of serverless computing.
Serverless is definitely a hot topic these days.
It is.
I've heard a lot about it, but haven't quite grasped how it relates to Kubernetes.
Well, serverless computing essentially allows developers to focus solely on writing code
Okay.
without having to manage any infrastructure.
Okay.
And Kubernetes is becoming the foundation for a lot of serverless platforms.
That's interesting. So Kubernetes, which is all about managing containers,
Yeah.
is now being used to power these serverless platforms where you don't have to manage servers at all.
Exactly. Kubernetes provides the orchestration and management capabilities needed to run serverless workloads efficiently.
Okay.
Platforms like Native,
Okay.
which is built on top of Kubernetes, let you deploy and run serverless functions, scaling them up or down automatically based on demand.
So it's like Kubernetes is leveling up, moving beyond simply managing containers to become this versatile platform
It is.
for all sorts of workloads, including serverless functions.
You get its ability to manage resources dynamically, scale seamlessly, and provide a consistent platform across different environments.
Yeah.
Makes it an ideal fit for this serverless paradigm.
Another trend I've been hearing about, especially in the context of Kubernetes, is the increasing emphasis on security with so many moving parts
Oh, yeah.
and containers running in a distributed environment.
It's a valid concern.
Securing a Kubernetes cluster seems like it could be quite a challenge.
You're absolutely right. Security is a top priority for any Kubernetes deployment.
Yeah.
Fortunately, there's a ton of work happening to make Kubernetes more secure.
Okay.
New tools and techniques are constantly being developed to address security concerns. Everything from scanning container images for vulnerabilities to implementing strict network policies and role-based access control.
So while Kubernetes might introduce new security challenges, it also comes equipped with the tools and mechanisms to address those challenges effectively.
Exactly, by being aware of the security implications of Kubernetes
Right.
and using the right tools and best practices,
Yeah.
you can build and run secure and reliable applications at scale.
Now let's circle back to persistent data.
Okay.
And those volumes we were talking about before the break.
Yeah.
You mentioned that Kubernetes offers different types of volumes.
Yes, different types for different needs.
Can you elaborate on that?
Absolutely. Let's start with empty dir volumes.
Okay.
These are temporary volumes that exist only as long as the pod exists.
Okay.
They're great for storing data that doesn't need to be persisted after the pod is gone. Think about things like cache files or temporary files created during a processing task.
So if I have a pod that processes large files, I could use an empty dir volume to store those files during the processing, and then the volume would automatically disappear once the processing is complete.
It's a convenient way to handle temporary data within the context of a pod's lifecycle without cluttering up your permanent storage.
Okay, that makes sense. What about host path volumes?
Host path volumes.
I remember seeing that term in the source material.
Yeah.
They sound like they're tied to the host machine.
You're right. A host path volume mounts a directory from the host node's file system into the pod.
Okay.
This can be useful in certain situations,
Okay.
like if you need access to files or resources specific to the host machine. But in general, it's recommended to use host path volumes with caution.
Why the caution? What are some of the downsides of using host path volumes?
The main concern is that host path volumes can create tight coupling between your pods and the host nodes,
Okay.
potentially impacting portability and scalability if you need to move a pod to a different node.
Right.
You need to make sure the same directory structure exists on the new node, which can be tricky to manage.
So it's a trade-off between convenience and flexibility. In some cases, it might be necessary to use host path volumes, but for most scenarios, it's better to opt for more portable and scalable solutions.
Exactly. Now, if you're looking for more robust and scalable options for persistent storage, Kubernetes offers persistent volumes, PVs,
Okay.
and persistent volume claims, PVCs.
Okay. Those sound more like what I'd want for storing critical application data or user files
Yes.
that need to be preserved long term.
That's right.
Can you explain how those work?
Absolutely. A persistent volume, PV, is a chunk of storage in your cluster that's been provisioned by an administrator.
Okay.
It could be network-attached storage, cloud-based storage, or even local storage on a specific node.
Okay.
The PV represents the raw storage capacity that's available in the cluster.
So it's like having a warehouse full of empty storage units ready to be filled with data.
I like that analogy.
What are persistent volume claims?
Think of a persistent volume claim, PVC, as a request for a specific storage unit in that warehouse.
Okay.
The PVC specifies how much storage you need, what kind of access you need, read-only, read-write, etc.,
Right.
and any other requirements you might have.
And Kubernetes acts as the warehouse manager, matching those claims to available volumes
It does.
and granting access to the requested storage.
Exactly. Once a PVC is bound to a PV,
Okay.
that storage becomes available to the pod that requested, just like a tenant getting access to their assigned storage unit.
This PV and PVC system sounds incredibly powerful.
It is.
It creates a clear separation between the physical storage and the applications that need to use it.
It does. Users can request storage without needing to know the nitty-gritty details of how it's provisioned,
Right.
while administrators can manage the overall storage capacity and make sure resources are allocated efficiently.
Okay, so we've covered a lot of ground today, from logging and troubleshooting to persistent storage.
We have.
What's next on our Kubernetes journey?
Let's shift our focus to how Kubernetes handles scheduling. It's time to explore how we can control where our pods actually run within the cluster.
Welcome back. So we've been on quite a journey with Kubernetes,
We have.
exploring how it orchestrates containers, manages resources, and handles persistent data.
It's a powerful platform.
Well, I have to admit it's a lot more complex than I initially imagined,
It can be.
but also incredibly powerful.
It is once you start to see how all the pieces fit together.
You know, as we've been talking, I've been thinking about our listeners who are new to all of this.
Yeah, new to Kubernetes, there's a lot to learn.
What would you say are the absolute key takeaways?
Key takeaways.
Someone should remember after this deep dive.
You take away just one thing. Remember, this Kubernetes is all about making it easier to manage containerized applications at scale.
Okay, at scale.
It helps you automate deployment scaling, networking, self-healing.
Right, all those things.
All those things that would be incredibly difficult to do manually especially as your applications grow more complex.
So if you're working with containers, especially in a cloud environment, Kubernetes is basically a must-have tool.
Pretty much, it doesn't matter if you're building microservices, deploying web applications, or running data pipelines. Kubernetes can streamline your operations and take your applications to a whole new level of scalability and reliability.
Our guide, Kubernetes Made Easy, has been a really helpful resource for us,
It has.
walking us through the core concepts and giving us a solid foundation for understanding Kubernetes. I especially appreciate how it uses analogies
Oh, yeah.
and real-world examples
Analogies are so powerful for understanding complex topics.
to make those abstract concepts easier to grasp.
It's much easier to wrap your head around something like a master node when you can picture it as a conductor leading an orchestra.
Or a service as a phone directory that always connects you to the right person.
Exactly. Analogies help make these concepts stick.
Now, before we wrap up this deep dive, I want to touch on one more topic that's been on my mind, scheduling.
Scheduling, okay.
We've talked about how Kubernetes manages containers and resources,
Yes,
but how does it decide where to actually run those containers within the cluster?
that's a great question. It's easy to overlook scheduling, but it's a crucial part of what makes Kubernetes so powerful.
Okay.
By default, Kubernetes tries to distribute your pods evenly across the nodes in your cluster,
Okay, so it's trying to balance things out.
optimizing resource utilization and ensuring that no single node gets overloaded.
Makes sense.
But there are times when you need more control over where your pods run.
Right, like what if I have specific requirements for certain pods?
Exactly. What if you need a certain pod to run on a node with specific hardware capabilities or in a particular geographic location?
Okay, so by default, it's all about balance and efficiency.
Right. But sometimes you need more fine-grained control.
But what if I have those specific requirements?
That's where Kubernetes scheduling options come in. You can use a variety of methods to control pod placement.
Okay.
The simplest option is to directly specify the node name where you want a pod to run.
Okay, so just tell exactly where to go.
But that can be a bit too rigid
Okay.
and lead to problems if the specified node isn't available.
So it's like assigning someone a specific desk in an office. It works if that desk is always available.
Right, but if it's not, that person is out of luck.
Exactly. A more flexible approach is to use Node Selector,
Node selector.
which uses labels to select nodes with specific characteristics.
You can label your nodes with things like their location hardware type, or even the environment they belong to, like development, testing, production.
And then you can configure your pods to only run on nodes with specific labels,
Exactly. It's like having a matchmaking system for pods and nodes.
making sure they're compatible based on their attributes.
That's a great analogy. Node selector gives you a balance of control and flexibility without being too restrictive.
And if you need even more fine-grained control, you can use node affinity rules,
Node affinity.
which offer a way to express more complex scheduling preferences.
That's right. Node affinity lets you get really specific about where your pods should run.
The source material mentions these two types of node affinity rules required during scheduling, ignored during execution,
Oh, yeah.
and preferred during scheduling, ignored during execution.
Those are quite a mouthful.
Can you break those down for us?
Of course, think of the required during scheduling, ignored during execution rule as a hard requirement.
Okay, a hard requirement.
If a pod has this rule, it will only be scheduled on a node that meets the specified criteria.
Okay.
If no matching node is found, the pod won't run.
So it's like having a very picky eater who only eats one specific dish.
Exactly. They won't settle for anything else, even if it means going hungry.
Now, the preferred during scheduling, ignore during execution rule.
That one's a bit more relaxed.
Okay.
It expresses a preference for nodes with specific labels, but doesn't strictly require them.
Okay.
If a matching node isn't available, the pod might still be scheduled on a different node.
So it's like a diner who prefers a certain dish but is willing to order something else if their favorite isn't available.
Precisely, it gives you a way to guide the scheduler without being too dictatorial.
And then there are taints and tolerations,
Taints and tolerations.
which sound like they work in the opposite direction, allowing nodes to actually repel certain pods.
That's right. Taints and tolerations are like a security system for your cluster.
Okay.
Taints let you mark nodes as unsuitable for certain types of pods,
Okay.
while tolerations allow pods to bypass those restrictions if they have the necessary permissions.
So it's like having a VIP area at a concert. Only people with the right wristbands can get in.
Exactly. By default, the master nodes in a Kubernetes cluster are tainted.
Okay.
preventing regular pods from being scheduled on them. This protects those master nodes from resource contention and ensures the stability of the control plane.
Okay, so taints act like warning signs,
Yeah,
and tolerations are like special passes that allow certain pods to ignore those
you
warnings,
got it. Taints and tolerations give you fine-grained control over pod placement.
making sure that critical pods are scheduled on the most appropriate nodes.
Exactly. It's all about optimizing your deployments and ensuring that your applications run smoothly.
This is a lot of information to digest, but I'm starting to appreciate the depth and flexibility of Kubernetes' scheduling mechanisms.
It's definitely one of the most powerful aspects of Kubernetes. By understanding these options, you can optimize your deployments, improve resource utilization, and even isolate critical workloads for better performance and security.
This deep dive into Kubernetes has been an incredible learning experience.
It has been a deep dive.
We've covered so much ground, from the basics of container orchestration
We have.
to the intricacies of scheduling and persistent storage.
Kubernetes is a fascinating platform.
I'm excited to continue exploring Kubernetes and see what else I can learn.
There's always more to learn.
And I'm sure our listeners are eager to embark on their own Kubernetes journeys as well.
I hope so. Kubernetes is a valuable tool for anyone working with containerized applications.
That's a great note to end on. Thanks for joining us on this deep dive into Kubernetes. We'll see you next time.
See you next time.